Okay, so today, like I said, steps are the same as what we've been doing the last 2 days. What we did on the notes on Tuesday and what we did on your Delta Math assignment yesterday. Steps are the same. I didn't change any of the steps. The only difference is the steps are going to look a little different. Okay, mainly step one. Step one, and then adding and subtracting, when we do that, that might look a little different, but nothing we haven't already done. Okay, that's mainly where the changes come. All right, so let's look at example number 1A. We have two fractions like we did for your Delta Math assignment. That hasn't changed. But how they look is a little different, okay? Our first step is to factor all of the denominators. We have two, right? We have two denominators. I'll highlight them, one in green, one in yellow, right? Before, on Tuesday and Wednesday, all of those guys were just monomials, right? Now they're going to be binomials and trinomials, okay? But we've factored those before. It's not like we haven't factored trinomials and binomials before. We've been doing that for a while now, since last semester, okay? So our first step, our very first step, is going to be to factor the denominators, okay? So we're going to factor the denominators. The first one, the one in green, is a trinomial. So I'm going to use the trinomial steps. Doesn't have a GCF besides 1. So I'm going to go to A, B, C. So A is 1, B is 6, C is 8. So I'm looking for the two numbers that multiply to be 8 and add to be 6, which are 4 and 2. Okay. Then I factor, so I get x squared plus 4x plus 2x positive 8. So then I factor, I get x plus 4 and x plus 2. Okay, so that's the first one. The first one factors to be that. The second one, the yellow, is a binomial. That one has different steps, less steps. So for a binomial, the yellow, we are going to, first of all, GCF. Besides 1, doesn't have a GCF. Difference of squares. Does the yellow represent difference of squares? No, right? Nope. So it's done. So I'm going to write that one down here. Okay. I don't have to factor the top and the bottom, the tops. That's only when you're doing multiplication or division. Multiplication or division, you have to factor everything. But when you're adding and subtracting, you only factor the bottoms. I'll only factor the denominators. Okay, so the 7 and x stay the same. My next step, that's first step. First step is factor the denominators, done. Next step is what's missing. What's missing from one guy or the other. So the first one, missing anything that the second guy has? The only thing the second guy has is x plus 2, and I already got it, so I'm good. But this guy's missing one thing. It's missing an x plus 4. So I'm going to include an x plus 4 here. Whatever you include to the bottom, you got to include to the top. Okay, that's step 2. So now my common denominators are the same. I have the same denominator on bottom, which is x plus 4. I need an x plus 4 and an x plus 2. Each of them has an x plus 4 and an x plus 2. That's the common denominator. The top. The top is 7 minus x times the parentheses. So I'm going to write that on top. 7 minus x times parentheses x plus 4. Okay, that's step 3. We subtracted them. I know we didn't actually do any subtraction, but that's what subtraction means. Put them all together in one line. Last step, simplify or reduce. Well, I can simplify here. I can do distributive property. Get rid of the parentheses on top. The parentheses on bottom is okay, but parentheses on top, I have to distribute. Okay, so I'm going to get 7 minus x squared minus 4x. Bottom stays the same. We don't need to do anything to the bottom. Once we have our common denominator, we don't need to do anything to the bottom. You're done. You can change it to standard form if you want. If you want to change it to standard form, you would just move some things around. It didn't say we had to in the beginning, so you don't need to, but either one. You put either one into Delta Math and enter twice, you'll get a green check. Okay, so same steps, but there's a little, they look a little different. That's the big thing. That's the main thing today. Just, that's it. Okay. All right, so let's flip over to the back. Let's look at B. 1B. So what's missing here? What's missing that we're used to seeing? First one doesn't have a denominator, right? X plus 7 is a binomial, but it doesn't have a denominator. So let's give it a 1. It's just a 1. If something doesn't have a denominator, it's always going to be 1. Okay, so I have 2 denominators. I have x plus 7 and just a regular old 1. Okay. So the first one, the green. 1 is just a monomial. And if I were to factor 1 using the tree, it would just be 1 times 1, right? So 1 is done. 1 is just 1. The top is going to be x plus 5, 2x plus 5. I put the top in parentheses because it came as like that. It came as a binomial. So the top is a binomial.
How do you know to put the 5 and the 2 together?
The 2x plus 5, you mean?
Yeah.
Because it came that way. It started that way. Like x plus 7, I'm going to do the same thing. Because when it starts that way, it's a binomial.
Couldn't they just be their separate, their like own fractions?
They are their own terms. Oh, I see what you're saying. Could they be that? You could do it that way.
But would it work?
It would work too. Yeah, it would. You would get the same answer. Yeah, it's a great question. Could I do it like this? So the problem was originally like that. So could I give this guy a 1 and this guy a 1 and do it that way? Yeah, you could do it that way. You could do it that way. Absolutely. I chose to do it this way because I'd rather work with 2 fractions instead of 3. But it's the same thing. You can do it that way. Absolutely. There's nothing wrong with doing it that way. Okay? We're going to see some of those types of problems next week when we do some solving. But yeah, absolutely. That would be okay. Okay? So the green is that 1. The yellow is x plus 7. It's a binomial. Doesn't have a GCF besides 1. Not a difference of squares. So x plus 7, and then the top stays the same. Step 1 done. It's been factored. Okay. What was I going to say? Okay, so now we got to make them the same. So the first guy has only got a 1 on bottom. It needs an x plus 7. So I'm going to give that an x plus 7. Whatever I do to the bottom, I have to do to the top. The second guy, it's missing a 1. Does it need a 1? No. Does it hurt? No. You can throw a 1 out here. You can say times 1 times 1. It doesn't hurt, but you don't need it because it's just a 1. Okay, step 2 done. So the bottoms are the same. So now I'm going to put them together. I have 1 and x plus 7 on bottom. On top, I have 2x plus 5, x plus 7, and then I have a plus 1 out there. So I have to simplify the top. Bottom, I'm not worried about. So I had this question last block. They said, can't you do this? Can't you do one of those? Cross those guys out? Could I do that? The answer is no. And this is the reason why. 2 reasons why. First reason why, the top is a big binomial. This is one term here. This is another. It's a big binomial. The bottom doesn't have that, right? It doesn't have a plus 1. If it did have a plus 1, go for it. The other reason is, if I were to do that, I would lose my common denominator. And in order to add or subtract, you always need a common denominator. So I'm not going to do that because then I lose my common denominator. If I lose my common denominator, then I have to go back to the beginning to try to find a common denominator. I don't want to do that. So that's why we don't do it. Okay? But what I can do to the top is multiply these guys. I can't use distributive property because it's a binomial and a binomial. But what I can do, we've done this before, multiplication box. We've done that before. Okay. So when I do that, I multiply. Okay. And then I combine like terms, right? When we do the multiplication box, we combine like terms. So we combine 5x and 14x. Okay, so let me bring it out back now. So now I get 2x squared plus 19x plus 35. I still have that 1 out there. I still have that plus 1 that I didn't use. And then on the bottom, I still have x plus 7. Okay. Combine any like terms, simplify the top if you can. These guys are like terms. 2x squared plus 19x plus 36. You are done. Okay. All right. Okay, so let's look at 1C. Okay. Subtraction. Well, we're subtracting fractions, so we're going to use these steps. Factor the denominators. So factor the yellow and the green. Okay. So if I factor the green, GCF, it's a binomial. The green's a binomial. GCF, nope. Besides 1, is it difference of squares? Is the green difference of squares? Yeah, it is. It's got a squared, it's got a minus in the middle, and 49 is on my list. My 49 is a perfect number or perfect square because it's 7 times 7. Okay, so we got x plus 7, x minus 7. And then the 2 on top stays. The yellow. The yellow is a binomial as well. That one has no GCF. That one's not difference of squares because it doesn't have a squared, and 7 is not a perfect number. Okay, so the second one is going to stay x minus 7 with a 7 on top. Step 1 done. Step 2, make them the same. Make the bottoms the same. What's missing? Well, it's the second denominator is missing an x plus 7. Okay. So now the denominator is the same. So the denominator is x plus 7, x minus 7. The tops. I have 2 and then minus 7, x minus 7. 2 minus 7, x plus 7, sorry, on top. Okay. So here's a question. I had someone ask this question last period, and it was a good question. To simplify the top, can I subtract 2 minus 7 to make negative 5? Can I subtract these two guys here? No, you're right. You're right. I can't do it yet because I have to do distributive property. Yeah, because distributive property is multiplication, right? Think of PEMDAS. PEMDAS. Multiplication's more important than subtraction. So I have to make sure all of my multiplication's done before I can subtract. So I can't subtract these two guys yet. Okay? So when I do distributive property, the 2 stays in front, and I get negative 7x minus 49. So the 2 stays in front. Now all of the multiplication's done. So now I can combine live terms. Combine the 2 and the negative 49. You get negative 7x minus 47. And then you get x plus 7 on the bottom, x minus 7 on the bottom. Done. Okay. All right, so we got 2 more we're going to do. And then I'm going to give you 1 to do in your notes, and we'll be done for today. Okay? So 2 more. So if you're kind of like, I get this, don't wait for me. Go, do it. Do the problems, do the rest of the problems. If you're still like, I'm not quite there yet, then wait for me. Okay? So if you got this, go for it. That's with anything. That's what I tell my son in math. If the teacher's teaching and you're like, I got this, go on, do it. Don't wait for me. If you get stuck or something, then you can wait for me. But if you're still like, I'm not quite there, Mr. Flores, then wait for me. Okay? All right, so here we go. D. Okay. Okay, so we have x minus 9 and x. So the first one, x minus 9, is a binomial. Doesn't have a GCF. Close to being difference of squares, but it's not difference of squares. So it's just x minus 9. The second guy is a monomial. So it's just x. So be careful when you're doing the next step, making them equal. Okay, so if you're ahead, it's fine, but be careful with this next step because I've seen a lot of mistakes here. So the first guy has an x minus 9. The second has an x. The second one obviously needs something because it's missing. What do I include? That's the question. Good. I have a lot of students do this. I have a lot of students say, oh yeah, it just needs a minus 9, right? So just minus 9 and minus 9. We can't use subtraction that way. That's subtraction. We can give things, but I have to use multiplication. So to do that, I have to give it an entire x minus 9. I can't use subtraction that way. I can use multiplication, but I can't use subtraction that way. So it needs the whole thing. It just doesn't need, oh, just minus 9, that's it. Now the first guy's missing something. What is the first guy missing? An x. Because it needs a separate x without a minus 9. It's close. It's like my kids. If I give my kids two things and they're close, they're still going to fight. They got to be the same. Okay? You got to be the same. Okay, so the bottom now is x minus 9. Okay? Now my focus is on the top. So I have 2x minus 2 times x minus 9. Here's the question I have. Do I do a multiplication box like I did on letter B, or do I just distribute here? That's my question, because you're going to get different answers if you do that. Do I need to distribute all of it or just the negative 2? Here's how you know. Was 2x minus 2? They never were a binomial. They're on separate sides, right? The 2x is on one side and the 2 is on the other. So they're not a binomial. So really, this part right here, oops, not that big. This part right here is by itself. So I have to distribute the negative 2, right? It wasn't like this guy over here. Look at from the very beginning. It was 2x plus 5. They were always together. That's why I had to do that there. This guy, the 2x minus 2, they're on different sides. Okay, so I distribute the negative 2, and I get 2x minus 2x plus 18. Combine like terms. Now I can add and subtract. The x's cancel out because 2x minus 2x . I had another question said, do I have to distribute the bottom? Doesn't matter. Once we've done step 1 and 2, we don't worry about the bottom. We don't worry about the bottom anymore. Then the focus goes to the top. So can you distribute to make x squared minus 9x? Yeah. If you put that answer in Delta Math, it would give you the same credit as if it would. Oops. Either one of those is okay, because they're technically the same answer. Most of the time we see it without distribution, the bottom, because the bottom, we only need the bottom of a fraction for a common denominator. That's all we need it for. That's all its purpose is. Okay. All right, letter E. Last one on this. Okay. Okay. So I have two denominators, x minus 3 and x minus 5. They're both binomials. Neither of them have GCFs, and neither of them are difference of squares. So I'm just going to write x minus 3 under the 7 and x minus 5 under the 3x plus 1. So notice the 3x plus 1 I already put in parentheses because that one came together. 3x plus 1. So that's why I put it in parentheses. It's a binomial. Okay. Step 1 done. Step 1 wasn't very bad because there wasn't anything to do. They were already factored. Step 2, what is missing or needed? What is missing or needed? Well, the first guy doesn't have an x minus 5. The second guy doesn't have an x minus 3. So both of them need something. Okay. So I'm going to rewrite. So I'm going to rewrite. So I have 7x minus 5 plus, and then 3x plus 1, x minus 3. Okay. So to simplify, I got two things I got to do. First thing, I got to distribute the 7. And then I have to multiply these two guys together, binomial times binomial. Okay. So when I do that, let's see. Let me multiply these guys over here so I have room. 3x plus 1, x minus 3. Three x squared plus 1x minus 9x minus 3. Okay, so the first thing was from distributive property. So when I distribute the 7, I get 7x minus 35. The next thing is from the multiplication table. So from the multiplication table, I get 3x squared minus 8x, because I had like terms here, minus 3. Okay. Last thing, now that I did all that multiplying, I can combine like terms. So I have a 7x and a negative 8x, and then a negative 35 and a negative 3. So I have 3x squared minus 1x minus 38. Okay. All right, that's about as hard as they'll get. That's about as hard. That one right there is as hard as they'll get. And it wasn't hard, just there was more steps, right? You had to distribute and multiply, that's all. So it wasn't that it was hard, it was that it was more steps. Okay, so I'm gonna give you one more to do, and then we'll be done for today. So wherever you're gonna tape this into your notes, see, the last one was 1E, we'll call this 1F. Okay. There we go. All right, so work on that one. Okay, so I factored the denominators. The first one was a trinomial, green. Second one, the yellow, is a binomial already, so I didn't need to do anything there. Okay, step one done. Step two, what are they missing? Well, this guy's missing an x minus, or an x plus 3. So this one needs an x plus 3. Okay. So I get an x minus 6, an x plus 3. X plus 2 on top, I wrote it in parentheses just to remind myself that it's a binomial, but I don't need those parentheses. The second one, I do need the parentheses because I need to distribute. Okay, from this guy here. So I need to distribute negative 5x minus 5x squared minus 15x Okay, so we get like terms. The only like terms are these guys here. So you get negative 5x squared minus 14x plus 2. And then on bottom, you just keep it the way it was since step one. Or since step 2, I should say. You're done. Okay. All right. Okay, so tape in your notes. There should be tape in the back. And we're done for today.